Hope you all had a Merry Christmas Eve. Here we are for our final day of Advent of Code. Bobby Ocean play. Yes, okay. What are we looking for? We are looking for what is the first step on which no sea cucumbers move. Okay, so it's gonna be like a life kind of a thing. Okay. Completely covered in sea cucumbers, there isn't an open space large enough for your submarine. You suspect that the elves might have done this before. Yeah, they're probably hunting for food, but don't worry, they're predictable. They move in perfectly straight lines, only moving forward when there's a space to do so. They're actually quite polite. There are two herds of sea cucumbers sharing the same region. One always moves east, while the other always moves south. Each location can contain at most one sea cucumber. The remaining locations are empty. The submarine hopefully generates a map of the situation. Your puzzle input. For every step, sea cucumbers in the east-facing herd attempt to move forward. Then the south-facing herd attempts to move forward. When a herd moves forward, each sea cucumber in the herd first simultaneously considers whether there's a sea cucumber in an adjacent location. Every sea cucumber facing an empty location simultaneously moves in that location. So in a situation like this, after one step, only one moves. After the next step, one moves. Two move. During a single step, the east-facing herd moves first, then the south-facing herd. So given this situation, after a single step... Yep, okay. Due to strong water currents, sea cucumbers that move off the right edge of the map appear on the left edge. Sea cucumbers that move off the bottom appear on the top. Sea cucumbers always check whether their destination location is empty before moving. Sea cucumbers need to stop moving. Again, consider the first example. Here's your initial state. Yeah, big. After one step, after two steps, after three steps, sure. After 58 steps, everybody is stuck. Yep, it's true. Okay. This one doesn't look like it's going to be all that bad. It's good. Day 25 is usually nice to us. Alright, so I think what we want is, we want a, we're going to want this to be parsed into some kind of an array, some kind of a, yeah, arrays of arrays is fine. We can just leave it as, actually, we don't even need this, right? So we can just leave this as a two-character array. That'll get us a double array. Alright, then we got max x is data count. Data length. Never remember which one's which. Max y is data 0 length. Let's go take a look at what our final puzzle input is going to look like. Yeah, that's not too bad. That should be easy to store in memory. The only question is, moving. Okay. So what we want to do is we want to know when it stops moving. So we'll say while move board. Yeah, I'll move board. That's pretty much it. We just need to know how many it took. So we want a count. And then we return the count. Alright, we'll move the board. So what we want a new board. It's going to be equal to a new, let's see, a new, yeah, that's fine. New character array. All right, and this one is going to be max x. For index is less than max y. double plus index. Let's see. New board of index. Oops. New board of index is going to be a new character array of max y. So we really, like, we'll end up with dots or zero characters, which is fine too. Probably going to be helpful to be able to print the board, right? So for x is 0, x is less than max x double plus, y is 0, y is less than max y, y double plus. Alright, we'll return false here, by the way, because we're not done yet. Okay, so console.write, let's see, we want board data x, y, equal to 0, we'll do a dot, otherwise we'll do data x, y. Alright, then we'll do a console, right. So let's go ahead and print the board to start, just to make sure that we're good. Why are you unhappy? Because we're using max x and y, which we haven't initialized yet. That makes sense. Okay. Let's go ahead and print the board. Missing a one of those. Alright, is that what our board looks like? Let's drop you over here. Look at that. There's our board. Okay, so to move the board, so we'll initialize, actually we want to initialize these things with copies of the existing board. I don't think, these might make sense to make these lists instead of arrays. Come on. Don't be like that. I know you're missing a using. Just chill out. Now we go back to counts. Alright, so for each one of these we're going to say new board, add a new list of char whose existing data is the existing board. So data sub index. So we start with a copy of the existing board, and then we want to basically walk every step and see if we can move, and move if we can, and don't if we can't. And we keep a new board because we want the new board to be moving, but we want to look at the old board while we're determining whether you can move. So we need to run this twice, right? Because we need to run the greater thans first, and then the v's. So x is 0, x is less than max x. Let's do this. Let's call this move type, and we want the list of char, the new board, and we want the char, which is the type. Alright, so what we'll do is we'll do result is move type of these, and then let's see. Yeah, I don't want to short circuit this. So like result 1, fine, this will be the easiest way to do it, because I don't remember what the and also equivalent is for these things. Return, let's see, so if result 1 or result 2, then data is our new board. Return result 1 or result 2. Okay, so then we move the type. All right, so we got y is 0, y is less than max y, double plus index, no, double plus y and x. Thank you. Well, so we want to say given a type, we need to know which direction it goes, right? Which I guess we can just tell here, right? dx, dy. So you guys go 1 and 0, and you guys go 0 and 1. Okay. Then we'll say new x is x plus dx mod max x. New y is y plus dy mod max y. And then if the board, no, sorry, if the data, let's actually call that the board. All right, so if the board new x, new y is equal to this, is not equal to this, and board new x, new y is not equal to this, that means we have a move, which start with a result being false. We return our result. First thing we'll do is we'll say yes, we moved. Then we'll say new board at x, y is 0, which is fine. Or a dot, doesn't really matter. We're going to print dots in our print anyway. And then new board at new x, new y. Let's see. We also need to if, let's see, current. So we'll do current is board of x and y. If current is equal to the type, because we want to only move the things that need to move, right? Then you move here. Okay. That looks correct to me. So let's yeah. Let's go ahead and print the boards here. And then we'll return -1, because I just want to see one move, make sure one move looks okay. All right. So this is our initial state. After one step. That's interesting. For one step. Yeah, we don't look like this at all. Did I do the wrong directions? I bet I did the wrong directions. No, it looks right. If you're going right, you're going up in x's. Oh no, that is the wrong direction. X and my y are backwards from x and y. It's fine. So that's one step. Yeah, that's not right though. So this looks wrong. So we're supposed to move the rights first. Okay, so let's try this as an initial state, right? This should be easier for us to get our hands around. All right, so here's our first state. And what's that supposed to look like? So after one step, That's interesting. You were supposed to move one to the right. You moved... Did I move the V's first instead of the rights first? I don't think I did. No, okay. Fine, we'll walk through move type. Okay, so we're currently looking at rights, which means you're going to the right one. Yeah, okay, fine. All right, so the first one, yay, clear. Yay, clear. Let's do the locals. So the first one we should hit would be, let's see, 0, 1, 2, 3, right? 0, 3. So there's 0, 3. And so our new x is going to be should be 0, 4, right? So it's 0, 4. Okay, so board of, so let's do x, y type. New x, new y, board of new x, new y. So it's a dot, which means it moves. So our result becomes true. We'll do new board at x, y. We'll do new board at new x, new y. Okay. Oh, I know what I did. Right, I need to rotate the board through after both of these. Yeah, I need to rotate the board through after both of these. Yeah, that's going to be what the problem is. Okay. That looks better. Let's get back to our slightly larger but still totally reasonable dataset size. And that's not even close to correct. Why is that not even close to correct? Alright, so if I'm looking at right, so this one stays, it did. This one goes right. This one goes over, can't go over there. That one stays. Okay, so that's good. So on rights, that one has to stay, but that one moves. Okay. That one has to stay, that one moves. It did. So this one has to stay, this one moves. It did. Alright. And then those are all stuck. This one moves. This is line 4, right? This is line 4. Why didn't this one move? Oh, it did. The V popped in here. Okay, so that one moved. That one moved as well. So then here, nothing moves. Right, that one stays. So here, this one pops. This one stays. This one bops. That all looks okay. And then down here, we have these, which this one stays. Did. Here. This one stays. It did, but where? Why didn't this one move over? No, why didn't this one move over? How did that one get down over top of it? Both of those stayed, and then this one should have moved here. And it ended up all the way over here? Okay, so that doesn't make any sense. Oh no, that's wrong. This one moves here. That was correct. This is troubling. I guess I want to see the board in both states. See if I can figure out what's going on here, right? Print the board. Print the board. Console write line. Print the board. Console write line. Actually, put the console write line in the print board. That's dumb. I put it everywhere. Okay, so our first moves. I don't know why we've got V's up here. Did I initialize the new board incorrectly? New board add, new list, char, based on board of X. Board of index. Print board, new board. List of char board. To print should be the board. So yeah, this is wrong. This is very wrong. Alright, because if I print the new board here, if that's the only board I print is the new board, this board and this board should be identical, and they're not. Why the hell aren't they? So we don't ever set anything into board here. We only ever get values from board. We only set values into the new board. And this new list, taking an existing and enumerable, makes a copy of all the data. So, I mean, what the hell, Mel? Why is this wrong? That is like the last thing I would have expected to be broken. All right. Print board of board. Oh my god, you know what? This is like the worst part of using C# for this, C# 10, and trying to not do this with types, is like, I don't know what you're talking about. All right. Okay, so the new board is empty. Right? So let's go with board of index. And let's go new board of index. ToString. About string join board of index. Thank you. How about string join new board of index? Board of 0. Huh? That was my bad. String join new board 0. Okay. The hell is index? Oh, God. This is dumb. Okay. Okay, those things are getting copied in there correctly. I really don't understand what's going on here. Oh, are they going in backwards? Wait, how is that possible? No, that can't be right. What even is this? Like, this is the closest thing that it could be to that. Okay. And here I want to see board and new board. I want to make sure board isn't getting manipulated here. So here's board and here's new board. All right, they're definitely not equal. All right, so this stays put and this moves, and that stays put. This stays put and that moves. This stays put and that moved. This stayed put. That moved. This stayed put, this stayed put, this stayed put, this moved. And then this moved. So far so good. Nothing moves here. You can't... Wait a minute. Where the hell is this? Where the hell did that come from? So you can't move, you can't move. You can move. But why are you over here instead of there? And then these are wrong too. Wow, this is just like I can't even fathom why this is so wrong. All right, let me go backwards. Well, I guess on forward. Let me use this because they give us how many sets of data here on this? They gave us 4 steps. Whatever, I ran 5. Who cares? Turn that. That's fine. That's too many boards, I think. All right. Because I'm already printing here. All right, so that's 1. That all looks correct. And then 2, we're like way off the rails on 2. Why are we way off the rails on 2? Okay, so we knew this one was going to be okay. We don't need you guys yet. All right, so this is iteration 2 now. Now I'll take that. So we know that we should be moving this one. It's like, what, 0, 5? 0, 4? 1, 2, 3, 4. Okay, yeah, 0, 4. You're going to move, right? Your new x is 0 and your new y is 5. So the current board there is a dot. So we get a true. Currently have that, but now that goes there. Okay, so the next one then is 2, 0, right? So 2, 0 can move and does to 2, 1. And then the next one is this one, which can't move. So that's like, what, 3, 6? So our new x is 3 and our new y is 0. So you can't move. All right, and then now we've got 4, 0. You can move into 4, 1. Okay. And now we should be on the v's, right? So now we're on the v's. So our first v now is 0, 2, and there should be nothing there. And 1, 2. So you go away. All right. Same thing, 0, 3 can move. All right, now 1, 2. One, 2. Oh, you've already moved? Yeah, there's no way you're not sharing memory. You're sharing memory. Like, how's that possible? I'm looking at board. Okay, what if I take the old board? You don't get a name. You can now be bored. You can be bored. You're not allowed to be null. It's fine. Print the board, underscore. 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 So move the board. You should return a board. How about you return a nullable board? If you moved, you get the new board. Otherwise, you get null. Okay. And say while true. underscore. If you are now null, then we break, which is fine. We print and we count and whatever. We only need 4 of them. Did that suddenly make it work? Hell no. How am I so broken? Oh, definitely have one other thing going on here, which is you should return the board. All right, so you should not do this. You should do this. And the new board is going to get constructed over here. Okay, and then you get the new board. Let's see. Result, you get the new board, otherwise you get null. And then you, result 1 is move type. If result 1 is not equal to null, then the board is result 1. Result 2 is move type board. If result 2 is not equal to null, board is result 2. So if result 1 is null and result 2 is null, then we return the null. Otherwise, we return the board. The board. Dear Lord, let this be correct. All right, so clearly we had something going on manipulating the data. That all looks correct now. Let's go ahead and run this with this data. Let's take this test out. Let's take the prints out. Let's take this test out. We got 57, which is wrong, because we just need to count +1. Yeah? Okay, we don't need this print either. All right, let's try the real data. Shake our heads at how sad this all was. 417. Let's just hope that that's the answer, because I really don't want to have to debug this. Correct. Part 2. Hey, congratulations, you finished every puzzle. Let's go see, do we get an animation this year? No, but the lights twinkle and the waves in the water move, which is kind of cool. So, yay. Really don't know why that one took me so long. As the score indicates, why did this take you so long? Also, yeah, I guess there's, about 450 people who haven't finished them all yet, so. Done here. Expecting I will probably stay in 3rd place. Zero Width could catch me if he finishes all his, but I don't know. We'll see. And that is closes the chapter on Invented Code 2021. Just wanted to say thanks for hanging out with me. More or less 25 days in a row. Minus weird times and internet outages and whatever else. I mean, that just happens. So thanks for hanging out with me maybe 22 times or less. See you next year.